What we did yesterday was we looked at solving quadratic trigonometric equations, and what it boils down to is you turn a quadratic trigonometric equation into two linear trigonometric equations, just like you turn a regular quadratic equation from Math 20 into two linear. So for example, if you had, I'm going to pick on A here, sine squared of theta plus sine of theta minus 2 equals 0. This factors into sine of theta plus a number and sine of theta plus a number. It's a pretty basic quadratic to solve. It's going to be 2 and 1. And in order for us to get positive 1 sine theta in the middle, this has to be positive 2, and that has to be negative 1. So then what happens is this breaks apart into two equations. Sine of theta equals, or minus 1 equals 0, and sine of theta plus 2 equals 0. I picked this example for review because there's also something about it that I think is important, especially connecting it to today's lesson. When we solve this equation on the left, you get sine of theta equals 1. And this is one that I think you should be able to just visualize the unit circle and say that's at the top because sine of theta is the y-coordinate. So you're looking at pi over 2, or any variation of getting to that location, negative 3 pi over 2, whatever the domain will allow. In this particular case, it's just going to be pi over 2 because the domain is 0 to 2 pi. When you solve this, you end up with this statement. And I'm going to try to make a connection here between what we have learned and what we're going to be learning today. There's the unit circle, and the y-axis is here. When you look at the unit circle, where this has a y-coordinate of 1 and this has a y-coordinate of negative 1, what this means is that sine of theta is always going to be a y-coordinate on that unit circle. So the biggest y-coordinate you could conceivably get would be 1, and the smallest y-coordinate would be negative 1. And as a point moves around the unit circle, all that happens is the y-coordinate goes from and you can watch on this screen over here if I'm in your way, goes from 0 up to 1, then down to 0, then down to negative 1, then back to 0, and it repeats. So what's happening is the y-coordinate is just oscillating up and down between negative 1 and 1. Because of that, you cannot have a sine of theta equal to negative 2. It's outside of the range of values that sine of theta can take on. All right, sometimes, we'll do just one more quick one, sometimes you have to use your calculator to get answers. For example, if you take a look at 1a here, and you factor it, it factors into 2 cos. That's not the one I wanted to do. What's that one with the 6? C. That was the one we did, right, Janessa? So I'm going to take a look at C. If you factor C, it factors into 3 cos theta, 2 cos theta. I had mentioned to somebody in Sabre Support this morning that you're probably not, when you factor something like what is in C, you're probably not, let me put my 0 on there, going to try 6 cos theta and cos theta. You're going to try numbers that are closer together first, and that's kind of what you're taught in earlier factoring lessons. It has to, I guess I should do one more thing here just so I don't lose anybody. I need to minus 1 from both sides to get that. So this has to be 1 and 1, and with a little bit of thought, you will see that if a negative goes here and a positive goes there, it's correct. Yes? Good. So when you set this factor equal to 0, you get cos theta equals 1/3. When you set this factor equal to 0, you get cos theta equals negative 1/2. This equation on the right can be solved by looking at the unit circle. Cosine of theta equals negative 1/2 is a pretty simple idea. Cosine is the x-coordinate, there's negative 1/2, so you're looking at these two locations. And, you know, depending on what the domain is, you can go clockwise, counterclockwise, you can go around a number of times if the domain permits it. You can be in degrees or radians, but finding those rotation angles from these positions is easy, I think. However, this cos of theta equals 1/3. Well, look up here, please. This is 0, this is 1, this is 1/3. There is a point on the unit circle, 2 points actually, where cosine is 1/3, but we just don't know the coordinates of them. We don't know the precise locations in terms of an angle or the x and y coordinates. So you have to use your calculator here. You have to go inverse cos of 1/3 to get a reference angle, and then draw that reference angle in quadrant 1 and in quadrant 4 and proceed from there. All that being said, does anybody have any specific questions you would like me to go over here from any of the assigned problems? All right. We're going to be moving on today to a totally different arena of math compared to what we have been working on. We've been working on definitions of sine and cosine and tangent and cosecant and secant and cotangent. And we've used that as well to solve equations that are either linear in trigonometric or quadratic in trigonometric. But now what we're going to be looking at are graphs of trigonometric functions. And this will round out the unit. We're going to be looking today at graphing some trigonometric functions. Tomorrow we're going to extend our knowledge from today to other transformations of trigonometric functions. And then Monday and Tuesday of next week will be review, and Wednesday is your Unit 3 exam. Okay? The first thing to note is that in this lesson, that really should say analyze the graphs of sine and cosine. So this is on page 23 of your unit handout. And if you take a look at the specifics of this, don't worry about the graph that's staring you in the face, because it's already there on your handout. But if I asked you, without knowledge of what this function looks like, this function I'm going to highlight in blue. If I asked you what that looks like and you said, I don't know, that's fine. But if I asked you what this function looks like, even though you don't know what the blue highlighted function looks like, you should be able to tell me that the green highlighted function will look identical to the blue one, except it will be vertically stretched by a factor of a. And it will be reflected vertically if a is negative. You should be able to tell me what this function looks like in relation to the blue function. You should be able to say that the pink highlighted function will be the blue highlighted function stretched by a factor horizontally of 1 over b. So this a and this b concept is the same a and b that we talked about in Unit 1. And finally, obviously, if I put it all together, you should be able to understand that y equals a sine of bx can be created by taking y equals sine of x and doing some things to it. Stretching it vertically by a factor of a, horizontally by a factor of 1 over b, absolute values of those numbers, and then reflecting it vertically or horizontally if a is negative or b is negative. And then we could do the same thing with cos. So this goes back to the idea that you learned about in Math 20, that do you know what y equals x squared looks like? Yes, you can graph any transformation of it. Now it's just going to be these functions. So this is what the graph of y equals sine x looks like. And this should make sense to you. I've already kind of alluded to this, and this is not going to translate well on the video because I'm just going to ask you to look at the tip of my finger and tell me if my elbow is the origin and I'm on the unit circle, what is the y coordinate right here? Well, it's 0, isn't it? That means when we have 0 for a rotation angle, and you want to be careful here that this is the rotation angle. This is not an x coordinate on the unit circle. It's the rotation angle. So when we have a rotation angle of 0, the y coordinate is 0. When we have a rotation angle of pi over 2, what's the y coordinate? 1. And the reason why at pi over 2, the y coordinate here is 1, listen very carefully, is not because this is the y coordinate, but because this is the sine of theta. We're plotting on the vertical axis here the sine of theta. That'll make more sense when I talk about cosine. We're still going to be plotting cosine on this axis, even though it will be the x coordinate on the unit circle. It's going to get muddy. Okay? However, just to let you know before we delve into this deeper, if you don't know how to create this graph, you don't have to understand where it comes from. I'm trying to teach you where it comes from. That if you look at the y coordinate, if you watch my arm, goes from 0 up to 1, down to 0, down to -1, and back up to 0. And it does that in a full revolution. So when you rotate the terminal arm 180 degrees or pi radians, you're back at a y coordinate on the unit circle of 0. This is what y equals sine of theta looks like, or y equals sine of x looks like. So again, f of x is y. If sine of x is f of x, y equals sine of x. This is the graph we're plotting. But x is not an x coordinate on the unit circle. X is a rotation angle. And we could go in the opposite direction. So you need to get used to this graph. A couple of things I want to highlight for you. One, and you have a ruler here. I don't know. You can decide whether you want to include some of this information or not. The graph is centralized vertically, equally above and equally below the x-axis. Okay? The graph has a maximum value of 1 and a minimum value of -1. And those 3 dotted lines that I've drawn are going to be crucial later on when you're expected to draw these on your own. That there's a central line, a horizontal line that the graph is centered about vertically, and there is a horizontal line that represents the maximum possible value and one that represents the minimum possible value. And I want you to understand something. I think it's obvious. Those dotted lines are not part of the graph. They're there for us to visualize what's happening. Okay? If you drew them in on a written response, that's fine, but as long as you understand that's not part of the graph. And they're not asymptotes either. The other thing I want you to note is that this point is at the origin, and we're going to be calling this the start point. The start point is where the graph is when x is 0, always. So the start point of sine of x is at 0, because when x is 0, y is 0. It starts at the origin. It starts, everybody, on that brown line, always. All right, let's answer some questions, and we're going to learn about some terminology here along the way. What is the domain and range of this function? Well, the domain is that x is any real number. And I really wish that every reference to these graphs on exams, my exams, the diploma exam, any reference in the textbook always used theta instead of x, but they don't. You need to know x here is a rotation angle. It's theta. What is the range? Well, we've already established, based on those kind of guidelines, that y is between -1 and 1. Now, there's an interesting point to be made. It's that in this particular case, y is sine of x. Do you remember a little bit earlier when I gave you an illustration from yesterday's assignment where we had sine of x equals negative 2? Remember that? Sine of x equals negative 2. Well, negative 2 is not in this range of values, so sine of x doesn't exist as being equal to negative 2. State the x-intercepts, or the intercepts. The x-intercepts are multiples of pi. If you look at the graph, there's an x-intercept at x equals 0. There's one at pi. There's one at 2 pi. There's one at negative 2 pi, negative pi, etc. We do need to follow this up, everybody, with telling people what n is. N is an integer. And there's a y-intercept as well that's equal to 0. What are the maximum and minimum values of the function? Listen, if we go back to Math 20, when we say what is the maximum value of a parabola, we're always interested in y or x, or y max or y min, not y or x. We're interested in y. Maximum value of the function is y, so y max is positive 1, y min is negative 1. And that's also indicated by those lines that I've drawn, right? The blue lines. Now we have some definitions here. Period, we use k. So let's get this out of the way. In Unit 1, when we talk about transformations, k is a vertical translation. K is not a vertical translation in this context. K is the period. How many of you have taken Physics 20? Okay, so when we talk about period of oscillation of a spring, we use capital T. It's the same thing here. And if you think back to Physics 20, when a spring oscillates, it goes up and down and back up. That's the period. The period is defined as how long it takes the function to go up and down and back up. It's how long it takes to go through one complete cycle. Now, I want to spend some time talking about this. This is not to be taken lightly because you are expected to be able to sketch these. This is considered one period of this trigonometric function. And when we talk about the period, we measure it horizontally. So the period of this is 2 pi. How long it is from this red circle to this red circle is 2 pi, and that's the period. So the period equals 2 pi. But I would like to impress on you the following, that the period, a full cycle of the graph, is really four pieces. 1, 2, 3, 4. It will always contain 4 pieces, and that's helpful for you to draw a nice smooth curve, by the way. And that means, by the way, that this could be the period as well. That this could be the period as well. Get my coat out of the way. From here to here. Because I go up, up, down, down, up. That's still 2 pi. I could go down, down, up, up. This would still be the period. It doesn't matter where you start. You get the same period because the thing has the same shape everywhere. Okay, so that's the period. The amplitude is the same thing in Physics 20 that an amplitude of a wave is. The amplitude is the vertical distance from the middle of the graph to either the maximum or the minimum. I want to go back here and just clear all this stuff off. When we talk about the amplitude, we're saying this is the amplitude. or this is the amplitude. The amplitude has no direction. We don't say the amplitude is positive somewhere and negative elsewhere. And in this particular graph, you can see the amplitude is 1. And we use capital A for amplitude. So before we go on, let's take a look at our graphing calculator. My hope is you would never need to rely on it to know what that graph looks like. You would remember that it starts at 0 and goes through a complete cycle, coming back to the x-axis at 2 pi. So between 0 and 2 pi, it goes up and then down and then down and then back up. However, let's put into our graphing calculator y equals sine of x. And I don't want anybody to do anything else other than what I'm telling you to do, okay? You go sine of x. And I want you to go zoom, trig. And what your calculator will do, it's not precise, but your calculator will produce an image that basically goes from negative 2 pi to 2 pi. Okay? It sets up the window settings that way. I want everybody to hit your mode key right now. How many of you are in degree mode? How many of you are in radian mode? It doesn't matter what mode you're in. When you go zoom trig, your calculator looks at the mode and sets it up. I am in radians, so in my window settings, it set it up from negative 2 pi to 2 pi. It's not exact, and I don't know why they don't go negative 2 pi to 2 pi. They go a little bit further in, but that's basically what it does. If you were in a different mode, if you change your mode now and look at your graph, it's not going to look right because I've put my calculator in degrees, but it still is using the window setting that it came from by using radians. So I can go zoom trig again. It looks the same. What I'm telling you is, and by the way, if you were in degrees and you went zoom trig, and then you put it into radians and went graph, it's crazy. It's all over the place. It looks like a weird heartbeat going up and down. But the bottom line is, I'm telling you, if you ever use your graphing calculator to graph a trig function and it looks wrong, check the mode. By the way, it doesn't go from negative 360 to 360. I don't know why. It's from negative 352.5 to 352.5. There must be some reason, but it doesn't matter. All right, let's turn the page. Let's take a look at cosine. Well, cosine looks identical to sine. Let me superimpose on this sine of theta, and I don't want you to draw sine of theta. I'm going to put sine of theta here. And it's not going to be perfect, but it will do the trick. Sine of theta starts here, it peaks here, it goes back to 0 here. It is at a minimum there, and it goes back to here. In 4, 1, 1, 2, 3, 4 smooth curves. The only difference is it doesn't start in the same place. So with cosine of x, this is the start point. And this is, again, tricky. This is y, which is cosine of the rotation angle. Boy, is it ever tricky. When I have to think very hard about how to say something, you know it's tricky. This y coordinate on this graph is the x coordinate on the unit circle, because it's the cosine of the rotation angle. And this x coordinate on this graph is not the x coordinate on the unit circle, it's the rotation angle. So if you think of the unit circle at 0 radians, what is the x coordinate on the unit circle? 1. So at the beginning, the cosine is 1. As you move to a larger angle towards pi over 2 radians, the x coordinate on the unit circle, which is the cosine, gets closer to 0. And that's why it passes through 0 on this graph. Everything else we've said, though, is basically the same. We have a midline, we have a minimum, and we have a maximum. The period is still going to be 2 pi. The amplitude's still going to be 1. I mean, what's the period? The period is 4 complete chunks. Let's start here. 1, 2, 3, 4. It's still 2 pi. The amplitude is still this distance. The intercepts are going to be different, obviously. So, domain and range, any real number. Range, -1 is less than or equal to y, which is less than or equal to which is less than or equal to 1. We could write -1 is less than or equal to cos x, which is less than or equal to 1. The intercepts are a little bit more difficult. The y-intercept is 1. The x-intercepts are not in sine of x, and you could look back if you wanted to. In sine of x, the intercepts for x were multiples of pi. But this graph has a y-intercept at pi over 2. Let me get rid of this because it's just blocking something. This right here is pi over 2, 3 pi over 2. But the distance between those two is still pi, just like it was for sine of x. It's just that it doesn't start at the origin. So we can get away with saying pi over 2 plus multiples of pi. Those are the x-intercepts. Maximum and minimum values of y. The maximum value of cos x is 1. The minimum value is -1. I've already established that the period is still how long it takes to go through one complete cycle, and that's still 2 pi. And the amplitude we can see is equal to 1. And that ends the lesson in terms of what those graphs look like. Now we're simply going to take our knowledge of vertical stretches and reflections and horizontal stretches and reflections and sketch graphs and describe properties of graphs without using our graphing calculator. I have a feeling at the bottom of each of these you have domain, range, amplitude, and period, and I don't have that here for some reason, but that's okay. So we know what cosine of x looks like. Cosine of x, and just hold off on drawing anything just yet. Cosine of x starts at 1, and from there it's going to go down to the x-axis, down to -1, up to the x-axis, up to +1. It's going to return to that vertical location in 2 pi. It's going to intersect the x-axis here, be down at -1 here, intersect the x-axis again there. And obviously that's cos x, and you wouldn't just draw straight lines, right? If you want to draw this, that's fine, but it's not the graph we're after. If you were to draw this, that is what cos x looks like. What is 2 cos x going to look like? Well, the only thing in terms of unit 1 that's changed is a is 2. Lowercase a is 2. Things have been stretched vertically by a factor of 2. Now think about this for a second. That middle line is still going to be the middle line, because stretching vertically by a factor of 2 means everything above the x-axis goes further away by a factor of 2, and everything below goes further away by a factor of 2. The bottom line here is we have new guidelines. So instead of having a start point at 1, the start point for this function is at 2. And I want you to try to get this in your head. The start point for cosine is at the top. If I say the start point is at the top, I don't claim it's always at 1. It's at the top. And in this case, the top is 2. It's going to return to that vertical position in one cycle. Halfway between, it will be at the negative value. In between maxima and minima, it will be on the x-axis. So what 2 cos of x looks like is this. And you draw it in, trust me on this, if you just try to draw it in one complete sweeping gesture, it doesn't usually come out that great. You draw 4 curves, and that is y equals 2 cos x. If we were asked to sketch it further and we had more grid paper, you would just continue. If we're asked to sketch it in the negative direction, we just use that same pattern. From negative 2 pi to 0, it has to return to the initial position. It has to go through one complete cycle. It's going to bottom out halfway between. It's going to level out, in other words, cross the x-axis halfway between the max and the min. So this is what it would look like. And we really ought to put arrowheads on the end of this. Again, it's the brown graph, not the red graph. You can see very easily here what the domain is. Can I just get this out of the way and say that the domain of these will always be x as any real number? Doesn't matter what we do to them. The range would be negative 2 is less than or equal to y, which is less than or equal to 2. Is the third one I have period? Amplitude, the amplitude is 2. And the period is 2 pi. Just moving forward, thinking forward, and I'm starting off slow, but we're going to pick up the pace here. It's going to go faster and faster. What's the only thing that can happen to that red graph to change the period? It's the only thing we've learned about in terms of changing graphs that can change the period of this graph. Will a reflection change the period? A vertical reflection? No. Will a horizontal one change it? Yeah, that. I'm seeing an accordion gesture. A horizontal stretch is the only thing that's going to change the period of this. Okay? I want you to notice that is a statement for the range. The negative of the amplitude is the minimum, and the positive of the amplitude is the maximum. That's not always going to be the case, because tomorrow we'll see we can take this and shift it up or down. That's going to change things. I also want you to note that the amplitude is the absolute value of A, little a. And you might say, why do we need the absolute value? Would you agree that if this were, and it isn't, negative 2 cos x, it would be flipped over vertically? Would the amplitude still be 2? Sure. So that's why I'm putting the absolute value there. All right, let's move on. Let's try another one. What about negative 3 sine x? So we start off with the notion, everybody, that sine x would start here, and it would end here, and it would be going up from the start point. This we need to know. We need to know sine starts in the middle and goes up. And if this were sine x, and hold off on drawing anything, just soak it in. If this were sine x, it would start at the origin going up, it would complete a complete cycle in 2 pi, and it would have a maximum and minimum of 1 and -1 respectively, if it were sine of x. Okay, so what does the -3 do? A is -3. Well, the first thing it does, not first, but one of the things it does, is it takes this and says we're going to go to the start point, but we're going to move down. The whole thing is going to be flipped over vertically. And the second thing it does is it vertically stretches it by a factor of 3. So these guidelines become there. Now, this red arrow is not drawn with the right curvature to it, because it has to go down from here and then back up to this point, and then up from here and back down to this last point. So it's going to have a maximum halfway between pi and 2 pi, a minimum halfway between 0 and 2 pi. So this red arrow really should be drawn more like that. But that's not part of the graph. That's just indicating what we're going to do. So you have to now draw a curve that goes from here down to the bottom, changes direction and goes up to the top, changes direction and goes down, put an arrow on it. I'm not going to spend class time now redrawing it on the other side. You can if you like. Nope. It would go through those points. So what is the domain? Any real number. What is the range? -3 to 3. What is the amplitude? Is it amplitude next? Okay. The amplitude is 3, and the period is 2 pi. So, all right, the range is the negative of the amplitude to the positive of the amplitude. The amplitude is the absolute value of A. So, by the way, if you think about what I just said, this is the negative of the amplitude to the positive of the amplitude. I've told you the amplitude is the absolute value of A, which means you could say this. But I think it's important that you distinguish between little a and big A. They're different. I mean, they might be the same, but they have different meanings. Let's try something here. Let's not worry about the graph of this. Let's just figure out what the domain, range, amplitude, and period are. Let's think about this without trying to construct the graph. Well, A, lowercase a, the parameter from unit 1 is -1/3. Well, that's going to flip things over. And by the way, if we flip cos of x over, it will start at the bottom. But we'll get to that in a bit. Will flipping cos of x over vertically affect the amplitude or the period? No. But the 1/3 will stretch this vertically by a factor of 1/3, which means the range is going to be -1/3 to 1/3. The amplitude is going to be 1/3. The period, because we didn't mess with anything horizontally, is going to be 2 pi. What this would look like is the following. And as I said, I'm going to pick up the pace by showing less and less in my explanation. Come on, get on there. There we go. There's going to be a maximum at 1/3. There will be a minimum at -1/3. The middle of the graph will be on the x-axis. Now comes some details. Cosine starts at the top. See, I didn't say cosine starts at 1. Cosine starts at the top, except it's reflected vertically. Instead of starting at the top going down, it will start at the bottom going up. It will return to the same vertical position after one complete period. max out halfway between. Basically, you're splitting the period into 4 equal horizontal chunks. So we can draw up, up, down, down. Any questions with C? Okay, so when you look at D, and I gave you rulers, you don't have to draw these lines in. You certainly don't have to draw them in with a ruler, but I think they're important in helping you draw the graph, seeing things visually. I see that A value of 1/2, and I immediately know it's going to go 1/2 above and 1/2 below. I see that it's sine, and sine starts in the middle. I'm saying middle, not necessarily origin, because that's going to change tomorrow. It's sine, so it starts in the middle and it goes up. Will this graph still start there and go up, or will it go down? It'll go up. When would it go down? If A was negative. So this is going to go up. It's going to end up back in that location after a full period, which means it has to go up, then down to the middle, and then down, then back up to the middle. So again, we split this into 4 chunks. I don't know if I put arrows on the ends of the one I drew in C, but I should have. Any real number for X. Y, negative 1/2, less than or equal to Y, less than or equal to 1/2. Amplitude is 1/2. Period is 2 pi. Still good? Okay, let's change gears now. What if we have a B value? Well, if B is 2, we have a horizontal stretch by a factor of 1/2. And I'm going to try to teach you not to think of this as a horizontal stretch. It is, and we're going to think of it as a horizontal stretch to begin with, but then we're going to develop a rule. Okay? If I were to look at sine of x, I'm going to sketch in sine of x. Would you agree these would be, whoops, would you agree these would be some key points on sine of x? Okay. So if I draw in sine of x, and you can draw it in if you like, or decide not to. I don't care. I care that you understand what's going on, and what I'm about to do you could put into words if you were asked to. That's sine of x. If I take that and I stretch it horizontally by 1/2, the fact of the matter is the top of this and the bottom of this will still be the top and the bottom. You can think of this curve as being like a piece of springy wire that's confined between those 2 blue lines. The difference is if I squish this towards the y-axis by a factor of 1/2, this point is going to be here. This point here, which I'm going to call point 1, becomes point 1 prime. So at the point 1 prime, do you see that the period is pi? The period is pi. I want you to notice that if you take the regular period of 2 pi and divide by b, you get that period. This is the point I want to make, that the period is always going to be 2 pi over b. So you don't need to think of stretches. Okay, we're going to use this idea again and again, and I'm going to slowly start weeding out the concept of stretches and just talking about 2 pi over b. What do we do to draw this? Well, we have to take the distance from here to here and split it into 4 sections. So halfway in between is where it will return. It's going to max out halfway between the start and the middle. It's going to max here. It's going to bottom out here. This is what the graph would look like. And if you want, you can sketch multiple periods. We could continue to do that. But how many of those you sketch is up to you. Again, I have 2 graphs on here, everybody. I use this brown graph as sine of x to illustrate how we get the red graph, but that's the answer to the question. And we can finish this off. X is any real number. -1 is less than or equal to y, which is less than or equal to 1. By the way, in this function, a is 1, is it not? Oh, so the amplitude is 1. The minimum is -1. And we're done. Any questions with that one? Okay. Cos of 3x. So cos starts here and finishes here. If I have a b value of 3, that means this. It means a stretch horizontally by 1/3. But think about this for a second. If this thing is going to start here and end here, and I stretch this point this way by a factor of 1/3, then it's going to be at 1/3 of whatever 2 pi is, 2 pi over 3. So the period is going to be 2 pi divided by 3. Well, there's that 2 pi over b thing again. If this were at, forget about this, if this were at 12 and I stretch it horizontally by a factor of 3, it would be at 4, right? Because 12 divided by 3 is 4. Well, that's why we're saying it's going to be at 2 pi over 3. Looking at the fact that this is 0, let me go back to here. This is 0, and this is 1 pi. This is 1 pi over 3, 2 pi over 3, 3 pi over 3. 2 pi over 3 is here. This thing is going to go through one complete cycle, down, down, up, up, in between those 2 red points. It still has to maintain centralization around that point or that line. It still has to max and min with these. So it's going to go down, down, and hit the bottom halfway in between, which means it's going to be in the middle and in the middle, halfway between the max and the min. This is what it looks like. And if you wanted to, you could sketch more cycles. Domain, any real number. Range, -1 is less than or equal to y, which is less than or equal to 1, and the amplitude is 1. With g and h, let's see if we can answer the bottom things about g of h without worrying about a complete graph of the function. Okay, a is 1, b is 1/3. Well, that means the amplitude is 1. If the amplitude is 1, the range is -1 to 1. And we know that the domain is any real number. I would like everybody to think about what I'm going to say and then ask. If b was 1, the period would be 2 pi. b is 1/3. I want you to figure out what the period is going to be. And put your hand up and then down when you have it. And continue to think about it, and when you do get it, put your hand up and down. B is a third. The original horizontal period is 2 pi. What's the period now? And those of you that have it, put your hand up if you found it using a stretch thought. Put your hand up if you found it without using a stretch thought. So how did you find it?
I went 2 pi over 3 and then times it by 3 over 3.
2 pi over a third, you meant?
2 pi over 3.
Yeah. So what Brody is doing is using the rule of going 2 pi over b, which is a third, and then he said he multiplied top and bottom by 3 to remove the complexity of that fraction. On the bottom, the 3's cancel, and you're left with 6 pi. But there is absolutely nothing wrong with you saying, it might slow you down later, with you saying, well, if it's stretched horizontally by a factor of 3, because b is a third, then 2 pi becomes 6 pi. Let's not worry about the graph. What you would end up doing is saying sine is going to start here. It's only going to go up to 1 and down to -1 still, but it's going to repeat every 6 pi. So you would break this into 4 pieces and plot your curve with those points. Whether you decide to draw it or not, I don't care. And finally, I know this gets repetitive, but tomorrow we're going to pile onto this more stuff, and you got to be really solid here. What will the range of this function be? Well, since we haven't stretched anything vertically or shifted anything, the range is what the range starts with cos x, -1 to 1. The amplitude will also be 1. In other words, should you choose to include a sketch here, these would be your guidelines in sketching it. This would be the start point because cosine starts at the top. It would go through one complete cycle over and over and over again, but the length of that cycle would be 4 pi. Now, sometimes it's easier to just think of stretches. A b value of a half means stretched by a factor of 2. If it's stretched by a factor of 2, 2 pi becomes 4 pi. But this works as well. The period is 2 pi over b, which is a half. Multiply top and the bottom of that by 2. This cancels and you're left with 4 pi. If you wanted to sketch this, where's 4 pi? That's 1 pi, 2 pi, 3 pi, 4 pi. If you wanted to sketch it, those would be your key points, and you could draw your 4 parts of the cycle, your 4 curves. And again, you could continue in both directions indefinitely. See some of you sketching it, so I will sketch it as well. So in spending that amount of time on this, I'm hoping the remaining questions can be done in like 5-6 minutes. There's nothing to them. Quick summary though. If we put A and B together, the rules still hold true. So this is like not having an H and a K, all right, which we're going to introduce tomorrow. Except we'll call them C and D tomorrow, unfortunately. Okay. The amplitude is always the absolute value of the parameter A. The period is always 2 pi over the absolute value of B. And then, of course, if there are reflections involved, there are reflections involved. What's the domain, range, period, and amplitude? Well, the period here is going to be pi. I am fundamentally a period equals 2 pi over b thinker. Unless I have to visualize the graph itself, I don't worry about stretches. I hope it's clear that that's the case. So the period is 2 pi over 2. The period is pi. If we wanted to work in degrees, I would put 180 degrees. What is the amplitude? 3. I mean, it seems like we spent an awful lot of time for me to just teach you the amplitude is the number in front. But that's part of it. The range, -3 is less than or equal to y, which is less than or equal to 3. The domain, any real number. It's that quick and that simple. It's a memory thing. What is the amplitude here? 1/4. Not -1/4, 1/4. What is the range? -1/4, less than or equal to y, less than or equal to 1/4. Remember, with this notation for the range that we've written, the number you start off with has to be smaller than the one at the other end. So that's the negative of the amplitude, less than or equal to the positive of the amplitude. The period is 4 pi. By a show of hands, how many of you just understand that without having to write anything down or think too hard about it? Again, I'm just curious, how many of you thought of that by thinking of a stretch by a factor of 2? How many of you thought of this as being equal to 2 pi over a half? More of you are thinking that way now, and I think that's good, because there are going to be cases where the stretch thought gets too confusing. The domain, any real number. Determine an equation of a sine function where the amplitude is 4 and the period is 90 degrees. Okay. So y equals 4 sine is going to be the start, obviously. I hope you would agree, because the amplitude is 4. Could I put -4 instead? Sure. That's why it says a sine function. There might be more than one. What number, our period is 90 degrees. What number will b be? Will b be? What number is b? This is requiring more thought, I think, isn't it? Excellent. It will be 4. Did you do it by saying, I don't want to put words in your mouth, but did you do it by saying that the regular period is 360, and to get from 360 to 90, I have to squish it by a factor of 1/4? If the stretch factor is 1/4, b is 4. Good morning, Will. Okay. You could, and this is an important idea, notice that if this is true, everybody, this is true. You can work that out by cross-multiplying and dividing. If you know b, the period is found by taking 2 pi divided by b. If you know k, b is found by taking 2 pi divided by the period. However, I just realize that we're in degrees, so I don't want to neglect that fact. So, since we're in degrees, you go 360 divided by 90, you get 4. And that means this is the equation. It's not as obvious working backwards thinking about stretch factors. And b, the amplitude is 0.5. Oh, let's just change things by a notch. Let's use -0.5 instead of 0.5. Is the amplitude still going to be 0.5? Sure. Sine, you know, I keep saying I am a thinker this way, and I can't control it. Sometimes the stretch idea just enters my brain. 6 pi is 3 times greater than 2 pi. So it's been stretched horizontally by a factor of 3, which means b is a third. When you look at the top of page 29 of your handout, that encapsulates everything that we learned for the first 45 minutes of the class. The graph is a cosine function. What is the equation of the function? And you're told it has this form, which means we better figure out what A is, we'd better figure out what B is. And then we're going to put them into that equation. I would like everybody to look at the graph and determine the value of A. How many of you have it? And how many of you have it and you're for sure you have it? You've thought of something else. You've thought of 2 things here in getting A. What is it, Janessa? What do you think A is?
3.
There's something else we got to look at. Patrick?
-3.
Good. So between those 2 ideas, we get -3. Because the amplitude is 3, you can see that the distance between the center and the maximum, or the center and the minimum, is 3. But you also have to look at the fact that it's a cosine graph. Come on. It's a cosine graph, and a cosine graph starts at the top going down, but this one starts at the bottom going up. So that's why, I'm assuming, Patrick, that's why you said it was -3. This isn't a matter of choosing an option. There is only one graph here that we're looking at. So A is -3. And B, well, we have to trace out what the period is. Don't feel as though you have to start here for the period. Do this. Up, 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 down, 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 down. The period is pi. So I'm a stretch thinker right now in this case. Actually, it requires a bit of thought. B is 2. Because we've stretched it from a period of 2 pi to pi. So y equals -3 cos 2x. And once you get that idea down, that A and B tell you about the graph, whether you're finding the graph or finding an equation from the graph or finding properties from an equation, it's at the top of page 29. That's the goal. That's the summary. So on page 233, numbers 4 through 10, you do not need to sketch them. A lot of these questions are just what's the amplitude, what's the period. I don't even care if you write down your answers.